your host today as we discuss framing. We're going to look at wall framing, floor framing, and roof framing in the simple model that I've provided as a good example of how you can apply and change the various settings for the framing. And then we're going to open up the chat panel where you can type in any questions that you might have about framing, and we'll be able to answer those for you live here during the webcast. Following the entire presentation, I'll email you out a booklet so you can read about all of the different settings that we spoke about today in the class. So let's get started in looking at the framing options that are available in your Envisioneer model. The first thing that I want to point out is when you're looking at the various versions of Envisioneer, they all have different options available to them. So I'm just going to take you to our website where I'm going to show you the products. So if you're a Pro Architect user, you'll notice that you don't have any of the advanced framing options, that those are available in our professional or our construction suite software. So when we start talking today about customizable framing tools, head sill and jamb tables, intersections, you won't have that capability in your software. You'll have default framing, which I'll show you, and I'll illustrate the differences between the software. But most of today's class is going to be focused on the settings that are available in advanced framing for those clients using our Envisioneer Professional and Construction Suite. So I just want to make that distinction for those of you that may be tuning in that are a Pro Architect user today. I'm going to pop our model into a 3D view. When you look at your model in a 3D view, you can always come up to the View pull-down menu and choose Framing and choose Display Framing. This will turn on the capabilities of any framing that's part of that model. So if I had a roof on or a floor on already, I'd be able to see their framing. So I'll hit Display Framing. The very bottom of the screen also has those options. So if you like to use the on-screen icons, you can also see that it's also here at the very bottom of the screen. I can choose Display Framing as well. The software from Pro Architect all the way up to Construction Suite will be able to see this initial distinction of having the framing, and there'll be default framing in there for our Pro Architect clients. With Envisioneer Professional and Construction Suite, by coming up here to the Settings pull-down menu and looking at Building Locations. In our Building Locations dialog box, this is where we adjust our heights of our walls and be able to tell it that it's a 9-foot wall versus an 8-foot wall, our head height, where we're framing those doors and windows, our ceiling height, all that data here. The very last column in the Building Locations dialog box is for our framing options. Each location can frame the walls separately. So that deals with maybe on the ground floor location, the headers over top of your openings need to be one designation, and then when you go onto the second floor, maybe down into the foundation, you want them to be framed differently. Each location can have the walls framed in a different fashion. So we're going to look at the framing options right here that are associated to our ground floor where I started drawing those walls. So when we look at those framed walls out in our model, you can see that they were 16 inches on center, and they're a basic wood stud. We can change that in our Professional or Construction Suite software by just clicking on that option, double-clicking on it. Will bring up our wall infill from the catalog. And in here, this is how we can choose a different way to frame those walls on that location. So if on this location we wanted them to be 16 inches on center, top and bottom plate doubled up, we could choose that option. Or if we wanted to put them blocking halfway up the wall, we can choose one of those options as well. If you don't find the way that you want to frame the wall in this default list, you can always right-click in here and tell it that you want to add a new wall in configuration. You want to add in a new way that you want to frame walls, specify different ways to apply the framing on the wall. The Infill Configuration dialog box will appear. On the very left are all of the members and properties. In the middle are the parameters for that member that's been selected on the left, and then on the right you have a preview. So the very first option that we have are the infill properties themselves. When we go to infill this wall, what is the spacing of those studs? You can see here we've put 16 inches on center. Next we have interference. So when we're talking about interference, it's when we're talking about T intersections of walls. So I'm just drawing a crude example right here. So if I was doing my 16 inches on center, if it came 16 and then hit here 16, When it's interfering with studs that are already part of the framing of an intersection, what do I do with that stud that's going to hit at that point? If that's going to be 16 inches on center right there, do I want to move it to the next nearest placement, so move it down or move it to the one side? Or my other option is to remove it altogether. So if there's one that's going to hit right in the middle of an intersection, just bypass it, don't put it in, or I can move it to the next nearest location. So you've got options there for how you're going to frame and when you're putting them in on those different intersections. The next comes to the bottom plate. When I'm running the bottom plate along the wall and I come up to an opening, do I want to continue that bottom plate through the opening or do I want to cut it? Those that want to run it all the way through, you might want to run it through the openings for two reasons. One, your manufacturer builder using panels, and you want to be able to ship them out on site with the added security of having that bottom plate on there so it can hold the opening in place. Or two, you want to maximize your estimate and make sure that you have overage covered with that as well. So you're going to run all of those bottom plates through your openings so that you've got that extra little padded amount of bottom plate in your estimates. Either one, uncheck it or check it if you want to run them through. Projections into the top extension and the base. This deals a lot with being able to frame with steel. So if this wall, we were going to specify channels and have steel studs, we might want to project the steel stud into the top channel and project it down into the bottom panel. Or for those of you that do pole barns and you want to extend the poles themselves up all the way through a location or project them down so that it's the same pole all the way in the ground all the way up, you could say I want to extend the base extension down 4 feet or whatever you need to do, and that would extend them down. You can see that option there. So primarily projection into the plates deals with steel framing going into the channels or pole barn framing where we're going to want to send that pole all the way up from one to the next. Also, with our studs and our orientation here, every time we start a new wall, it's going to start off with a stud at the corner. So right here, there's a start and an end stud. So I can say I want to remove the start stud and the end stud. Again, very handy when you're dealing, again, I'll give the example of a pole barn. You're only going to have one pole at every corner, but if each wall had a start and end stud, well, then there'd be 2 poles there. So on one of the walls, you can designate it to not have the start and the end stud. Next in our list over here on the left, we're getting into our bottom plate. And you can see as I highlight the member on the left that the little preview to the right is going to highlight it as well. So now that I've chosen our bottom plate member, it's highlighting it for me so I can visually see the member that it's using as its bottom plate. In our middle selections here, it's telling us that the bottom plate is being pulled off the wall properties. So it's looking at the wall itself, each wall individually, and each wall that you draw can have a member associated to it. So when I pick out of my catalog as an example a 2x6 brick wall, there's a 2x6 member that's associated to that wall. And this infill configuration for this bottom plate is telling us, look at whatever's designated to that wall. If it has a 2x6 associated to it, use the 2x6 for the bottom plate. If there's a 2x4 associated to that wall, use the 2x4 for the bottom plate of that wall. Instead of using the wall properties, you can also go into the catalog and choose an entirely different member. So we could choose member library here. When we choose member library, that allows us to go back into the catalog and choose an entirely different member. So we may be using the 2x6 or the 2x4s for our studs, but maybe we need a pressure treated bottom plate. So we'd say member library, go back to the catalog and choose that pressure treated bottom plate for us so that this wall infill is using the pressure treated bottom plate. Then it can also be rotated. So right now you can see it's on the flat, but if I did want to rotate it 90 degrees, I could bring it up and rotate it up. So again, I'm going to give that a little example there of pole barns when you're using a grade board at the bottom. You'd want it to be rotated up your 90 degrees and choosing whatever wall member that you would want for your bottom plate and calling it a grade board. These names here, we're saying bottom plate, they could be any name that you want. You could overwrite and retype that if you wanted to as well. Below that is our quantity information. So when this bottom plate appears in our material list at the very end, we want it to be tagged that it's a plate. And we want it to be organized with all the other wall framing materials. So this quantity information is just organizing it in our material report at the very end. Next we have our studs, and again our studs are telling us here in the middle, look at the wall properties. If it's a 2x4 wall, use that 2x4 and frame the wall with it for its studs, or the 2x6, go with whatever has been designated with that wall. Keep them rotated 0 degrees, but again you can turn those if you need to. Quantity information, we want to label it as a stud, and we want to put it with all our wall framing data, so make sure in our quantity report they're organized correctly. The next deals with how you're going to position the studs along the wall. It knows from our infill properties that we first looked at in here in this infill configuration that we want them 16 inches on center. It knows to use the member from the wall properties, but how does it know where to anchor it along this wall? So we're dealing with the center alignment. It's going to center it along the line of the wall itself and the stud portion of that wall. These studs are going to be centered along it, but we could offset it one way or the other. So if I put in a little offset here of 2 inches, you can see how it's positioned itself and moved itself 2 inches along that wall. And now bring it back. Okay. Also front to back positioning along the wall. We've got it midpoint along the wall line itself as well, but again, we can do an offset. So watching here, when I put the 2-inch offset here, you can see it moves it 2 inches to the one side, or I could put a negative value there, and I've got it 2 inches going the other side, or leaving it 0 so that it's perfectly centered along the wall. So this allows you to realign where they're positioned and change the member of that stud that you're putting along that wall. Blocking, if I want blocking along the wall, I would just add that in. You can see we've got blocking halfway up the wall here. Again, it's getting its member, what member to use for the blocking from the properties of the wall itself. So it's looking at that 2x6 or 2x4 wall, grabbing that same 2x6 and using it for blocking. Or again, if you wanted it to be a separate member, a particular member, you can tell it to go right to your member library and choose a different designation. Our sorting information as far as the quantity report is going to be labeled as blocking, and it's going to be put with all the other wall framing materials. Here we have an option, break its stud. So if we look at our little preview over here, we can see that they're all individual little pieces of blocking along that wall because we've broken it at the stud. But if I say no, you can see it runs a continuous member all the way through. As far as placement of that piece of blocking, it needs to know where it's being placed from. So our placement, the initial placement is from the bottom plate, but it also, you can see, can be from the top plate. And its initial offset is 4 feet. So 4 feet from the bottom plate, we put our row of blocking. So I could change that to 2 feet. And then you can see the spacing value. The first row of blocking is at 2 feet, and then every 5 feet thereafter. So if I made that every 3 feet thereafter, you could see it moving down, or every 2 feet thereafter, we've got some ladder framing going on. And again, this rotation could be 90 degrees on the flat. Okay, so you've got different ways of looking at the blocking and how you need to apply that blocking itself. This stagger option here is only to be used if you're breaking it at the stud. So if I turn this back to yes, you can see the stagger is yes, and it's going to stagger them. But I could change that to no. Now they're still all little individual pieces broken at every stud, but they're all in line with each other. And then we've got position, because it needs to know within that stud wall, where do I want this blocking to occur? And you can see if I put that slightly on the turn, mid to mid means it's right in the midpoint of all of those. But I could, again, offset it one way or the other and move it out or in if I need to. Okay, so that's our blocking. A top plate, again, it's going to highlight it over here in our list. There's our top plate, again, grabbing its materials from the wall properties. If I wanted to rotate it, I could. Quantity information, I'm I'm going to label it as well as plate material and organize it with all the other wall framing information in my quantity report. I am going to, in its alignment front to back, it's going to be midpoint. So, and it's anchored to the bottom plate. So looking down at the bottom plate, it's got the same mid to midpoint as our bottom plate. And that holds true over here as well for our very bottom plate, our very top plate, sorry. We can grab again from the wall properties, usage, wall framing as the phase, and again it's positioning front to back. If you need to create any other members that you might want, you can always copy or create a new one. So if I wanted a double bottom plate, I could say copy the other bottom plate, and you can see it puts a double top plate in there. So you can have as many bottom plates as you want to all stacked up there. So you can always create new or delete out the other ones that are already here. Now, if you get an error saying, I can't delete that one out, it's because of its reference. It's being referenced from the other bottom plates in its position. So once I've got that in there, it's referencing the other bottom plates in its position. So I have to go from the bottom and get each one out so that I still have my very bottom plate. Okay? So that's looking at the infill and how it's going to fill the wall with framing and how you can change that up and customize the framing so it matches the framing that you're actually going to do on site, so you know it's going to appear correctly in your drawings and also quantify correctly as well. So cancel out of there. So we've got our basic wood studs at 16 inches on center still. Also what we're looking at is when we're looking at the openings. In the model that I drew, there was a garage door that was 9 feet long. There was a double door that was 6 feet long. And there was some other doors that were 3 feet, and there was a window. All of them have different spans. So we're going to look at the span table to understand how it's going to frame along those openings. So you can have various span tables you can see here in this list. It allows you to designate different span tables per location if you wanted to. So again, on my ground floor, I might want to use one set of head sill and jamb configurations around an opening. And then on my second floor, where there's not as great a load as there is on the ground floor, I might have smaller member sizes used for my headers so I can use a different span table. If I double click on any of those span tables, it'll bring up this wall framing span table dialog box. And this is where you can chart out the configurations of your spans and the member that it's going to be using for those various spans. So you can see in our general 2-ply span table that the first span we have is 3 feet. So anything up to a 3-foot opening is going to use 2 2x4s. If it's over 3 feet but less than 6 feet, it's going to use 2 2x6s as the header over that opening. If it's over 6 feet but less than 10 feet, it's going to use 2 2x8s. All of these are can change. So as an example, if you use the same member all the way up to 10 feet, I can remove the 3-foot and then hit remove on the 6-foot span, and they're gone. And then for my 10-foot span, I can say I always use 2 2x10s. So anything up to a 10-foot span, I'm just going to frame them all with 2x10s, 2 2x10s. But then anything over 10 feet, because I do have maybe a larger double garage door, I can always add a span as well and say that this one is for up to 16 feet. So anything over 10 feet but less than 16 feet, maybe I'll use my 9.5 LVL there for my opening. So you can choose how you're going to frame each of these openings as well and the products that you want it to choose. This little button here that appears off to the side, this allows you to choose an entirely different configuration as well. So if I click on that little button, you can see it brings me into the head sill jamb library that looks much similar to the wall infill library that we were just looking at. And by double clicking on any of these, it brings up that same type of dialog box. So learning one framing dialog box, they all look the same. We learned how to infill a wall. Now we're learning how to frame around an opening. Members are on the left, the parameters are in the middle, and the preview is on the right. Looking at our king stud, the first one in our list of members, its parameters in the middle. It knows it's going to grab, again, that same member from the wall. The wall is designated as a 2x6 wall. I'm going to use a 2x6 for my king stud. If it's a 2x4 wall, I'll use a 2x4 for my king stud. But again, if we want it to be a very specific member, click down and you can choose one from the catalog. When it's going to be labeled, we're going to label this king stud as just a stud. We could label it as a king stud, a jack stud, whatever name you want to give it. It's just how it's going to appear in the material list. So these king studs are going to be labeled as stud material, and they're going to be grouped in with all of our wall framing data. Now, how it gets its position, how does it know where to position itself, comes down at the bottom. And this will be just like when we were positioning top plates, bottom plates along the infill of the wall. The king stud, the left king stud, is going to anchor itself to the left king stud 2. So there's 2 king studs there, you can see. There's 2 king studs in the list here, king stud 2 here. And it's got a right to left alignment. And it's right up against it. There's a 0 space between those 2 members. But if I wanted to leave a little bit of a gap between them, the shift position allows me to do that. Now, as far as front to back, when we're looking through the width of the wall, it's going to be anchored to the wall core itself, right in the midpoint of the wall line, just like our studs were, 0 shift. But we could shift it back or forth if we want to as well. As far as the top end of that king stud, it's going to go all the way up to our top plate, and it's going to go anchor at the bottom of the top plate. So it's going to bring itself up to the top plate and stop right at the bottom edge of that top plate. The bottom of that king stud is going to go all the way to our bottom plate, and it's going to finish itself off right at the top of that bottom plate. So you can see how particular you can be when framing an opening and positioning all of the different members at that opening itself. We look at our jack stud, same basic information. Really the important information is how it's positioning itself. It's anchored itself to jack stud number 2. So you can see there's another jack stud running right in there as well. It's, again, right to left. It's mid to mid positioning. It's anchoring itself to the opening, to the top of the opening. And it's bringing the bottom end of it down to the bottom plate. So this is its top end going just to the top end of that opening, and the bottom plate, the bottom of it is going all the way down to the bottom plate. The king stud itself on the right-hand side will mimic that of our king stud on the left, and same with the jack stud on the right will mimic our jack stud on the left. The header material. The header material itself, this is where it's going to go pick that header. And you can see that right off the bat, it's got something right from the member library. It's not going to frame itself with the same member from the wall properties. It's gone out, found itself some product here, and it's going to use it for its member. And it's been tilted up 90 degrees instead of being on the flat. As far as its position is anchored to the opening. And that's its vertical position. It's the bottom to the top. So the bottom of the header is going to be at the top of the opening. Front to back, it's mid to mid still. Left end is anchored to the left jack stud. The right end is anchored to the right jack stud. Okay, so again, you can get all very particular. We've created all of these in the default catalog that ships with the software, so you'll see these as examples. And if you ever want to tweak or change something about how it's framing, maybe add in triple jacks or triple kings, whatever you need, this is where you come in and make those modifications, and it nicely visualizes it on the right for you. So any kind of configuration of how you want to frame around an opening can also be found. And then when it knows how you want to frame around those openings, you can add them to the span table so it knows exactly what span to start and stop using that particular product. Okay, so I'm going to click OK here to change our 2-ply span table, and click OK and OK, and the new products will be used. So you can see on the exterior now it's using 2x10s over those openings. If I turn on the visibility of the doors for just a moment here, I'm going to grab this garage door, right click, and tell it I want to replace that door, and I want to replace it with a 17-foot fold-up door. See how it absolutely disappears? There's nothing for the header material. Looking at our building locations information and our span table, when it went to the span table, it says, well, I don't know what to use for a 17-foot opening. You haven't told me. So it's going to leave it open. So if you want to ensure that you have all of your openings specified, you might want to put a larger opening in there and choose a larger member. Some people like to leave that blank. It reminds them that they have to have that particular opening engineered and find out the information about how they're going to frame it first. So that you can either leave it blank or you can fill in that information. If I right-click and say, well, let's replace that again and bring ourselves back to our 12-foot door, then we can see that LVL product being used. It's automatically looking at those span tables and saying, oh, well, we've got a 5-foot opening here. I've got up to 10 feet. I'm going to use my 2x10, so I'm going to use that one. But then, hey, this is over that span. I'm going to use the next product up. You'll notice if I look into the interior, our interior wall isn't using the 2x10s. I'm going to come up here to View, Framing Mode On-Off. You'll notice when I went to Framing Mode On-Off that all the walls are coded. The load-bearing walls are coded in this orange color. The non-load-bearing walls are coded in this green color. Any openings that we have are coded in this pink color. And this allows us to pick on those walls, but we can see that this wall itself has been coded as a non-load-bearing wall. And if I go back up to Settings, Building Locations, and look at my framing options, my non-load-bearing walls are using a different span table altogether. So they know to frame themselves differently. And when they have an opening in it, they're not going to follow that same span table and use 2x10s. They're going to use just the 2x4s that we can see that it's been using in this wall. Okay. If I want to change one wall and change how this one wall is being framed, as an example, out here we've got this garage door. Right now, all of these walls are following the information of our building locations information. 16 inches on center, double top plate, single bottom plate. I'm going to select on this wall and then holding down my Shift key, select these other two walls. We're going to pretend those are garage walls. I want to make sure that they have a pressure treated bottom plate. I want to frame them differently than the other walls and maybe apply some blocking as well. So I select those walls and I right click. One of the right click options is to look at the properties, how it's framing that wall. It'll bring up this Edit Infill dialog box. I want to edit how I'm infilling these walls and how they're being framed. Right now, as a default, saying, well, I'm looking at your building locations information and how it's told me to frame walls on the ground floor, I'm following that rule. But you can tell it for these walls, let's use a custom infill. We're going to frame these walls, placing studs on maybe different centers, or maybe double top plates, double bottom plates, and change it up on how we frame it. When we tell it we have to use a custom infill, then we click on this button right here, Select Custom Configuration. That takes us back into that exact same dialog box that we were in before and looking at all of our different wall infills. So from here, we can just come back in here and tell it that we want to use a pressure-treated bottom plate. 16 inches on center still and using a pressure-treated bottom plate. Or 16 inches on center with blocking halfway up and a pressure-treated bottom plate. I click OK, OK, and now those walls are framed differently. We can take that exact same process and apply it to any openings as well. If we know that there is a load coming down on this wall right here, and we're going to need to beef up the header over top of this door, then we can pick this opening. Highlights that rose-colored wash over the opening. Again, right-click just like we did with the walls. And then again, we can look at the properties of how it's going to frame that opening. Again, it's telling us I'm framing this opening referring to the locations information. I'm looking up at the infill and how it's telling me in my building locations information which head sill and jamb table to look at according to your span table. But we're going to say, well, we want to use a custom head sill and jamb configuration. And then we again hit select configuration. Takes us back into that head sill jamb library that we were looking at. And here I can tell it that on this particular opening, we're going to need 9.5 timber strand product. I click OK, and it reframes it with the timber strand. To get ourselves out of this framing mode, again, we can go back up to View, Framing Mode, On, Off. And again, that's down here at the bottom for those of you that like to use the on-screen icons. Where I found the display framing, I can also find framing mode on and off. So now we can see the walls reframed around the garage using the pressure-treated bottom plate and the blocking, and the redesignation of the header size over those garden doors using the different header. So when we're framing a wall, and we choose a wall, let me get it out of display the framing. I'm going to say display all but the framing. When we look at the properties of a wall, two things must happen before it can be framed. One, it has to be designated as a framed wall. If it is a general wall, it won't frame. If it's a concrete wall, obviously it won't frame. None of these walls will frame. It has to be designated as a framed wall. When it's designated as a framed wall, looking down at the bottom of the Walls dialog box, this is that member that it's going to use as a default. So when it's looking at those studs and it said use whatever in the wall properties, this is the member that it's using. So every wall in your catalog can look at a very specific member, and it's going to use it when it's framing that wall. So you're choosing this 2x6 clay brick wall, and it's going to use that 2x6 to frame that wall according to the building locations information. If I look further down in this wall properties, another property that you want to look at in the walls is the designation as frame as load bearing. Is it automatically going to choose for you what to use as load bearing or non-load bearing, or do you want to designate a wall as yes, be load bearing, or no? The auto option looks at all exterior walls, automatically will be chosen as a load bearing wall. If it's an interior wall, it'll automatically designate it as a non-load bearing wall. But you can always come back once it's drawn and change that designation, that a particular interior wall needs to be designated as, yes, I am a load-bearing wall. When it's designated as a load-bearing wall, then when it looks up at that opening span table, it'll know what header sizes to use. Do I look at the non-load-bearing, or do I look at the load-bearing? And it'll frame it accordingly. So look at all of those various options when you're looking at framing the wall. Each wall must be designated as a framed wall with a framing member, and designate them as automatically decide for you exterior walls, load-bearing, interior walls, non-load-bearing, and it'll use those designations when it's framing the wall for you. So that's wall framing. I'm going to put this down into 2D, and now I'm going to look at floor framing. For our customers using ProArchitect, you have the floor by room, floor by perimeter, and floor by picking points tool. These tools can have framing designated to them. So if you look at, as an example, the hardwood flooring in the catalog, you can change that to a framed floor and specify the joists and the rims for that floor itself, and it will apply the joists at that span, 16 inches on center, whatever direction you want the joist to be designated in their direction, either coming across the screen, 0 direction, or running up and down the screen in a 90-degree direction. It will frame and put those floors in. We've taken that same type of philosophy and applied it to our structural floor tool. In our structural floor tool, again, you have the opportunity to apply the floor to the entire perimeter, to a particular room, or you can pick points to say the structural floor starts and stops here. I'm going to use the structural floor by perimeter tool. So it's going to go all the right way around the entire building, and then I'm going to show you how I can get it out of the garage and change its orientation in different directions in different areas as well. In the catalog then, I would choose a structural floor element. And I'm going to double click on one of those elements just to bring up its properties so we can understand the information in a structural floor. This dialog box is much similar to the head sill and jam configurations we were looking at, the infills. Components on the left, that particular component's parameters are in the middle, and we get a preview here on the right. So we look at, first of all, the general properties of our structural floor system. The joists that it's going to use are going to be running in the direction of 90 degrees. So when we look at our screen, if I wanted my joist to run left to right on the screen, that's a 0 degrees designation for the joist direction. When they're running 90 degrees, that means that the joists are going to be running up and down the screen. So when it applies the joist, it's going to put them, for this particular floor, running up and down our screen. The joists themselves are going to be 16 inches on center, and again, that can be any value you want. Next, we have joist at a bearing line. If I have and I'm just going to tilt this floor up to use it as an example. If I run a beam right down the middle of our floor, and I have our joist running down the floor in our 90-degree direction, it wants to know, what do I do at that bearing line and with the joists that are coming up and meeting at that beam? Right now it has stagger and a distance of 1 foot. So that means it's going to overlap the bearing line by 1 foot, and it's going to stagger the joist. So they're going to be side by side like this, and they're going to overlap each other by 1 foot. The other option that you have instead of stagger is hold back. Hold back means that the joists themselves are going to stop at that bearing line, just like this. They're just going to come in, stop, new joist on the other side, start, stop. Now, you can hold them back a distance. If I wanted to set them back so they don't even touch the beam, I could say, hey, hold them back by a foot, and they would stop 1 foot away from that beam. Okay, so you can hold them back a distance as well. We're going to leave ours at stagger so we can see that overlap, and I can illustrate that to you once we have the joist in today. So our joist direction is 90 degrees. They're going to run up and down the screen. They're going to be 16 inches apart. And when they hit a bearing line, once we insert a bearing line, they're going to overlap by 1 foot over top of the beam, and they're going to be staggered. Next, we can choose our sheathing. So when we put in the structural floor, it's automatically going to apply sheathing on top of it. And yes, I want to include the sheathing, and then choose from the catalog a particular product that you want to use. And I'm going to use this 3/4 OSB for my sheathing. The information below that, just like in our wall infill properties and head sill jam, wants to know where to organize that sheathing in our material list at the very end. So it's telling us that it's going to put it in the floor system phase, and it's going to label it as subfloor. Next, we have our joist in the list of components on the left, and then its parameters will appear on the right. And if I throw this up, you can see that they're highlighting the joist coming through. So they're going to be called joists. We've chosen 2x10 product, but again, by picking on this little button here, that will take us to our catalog where we can choose an entirely different member to frame this floor with. Rotation is 0. I don't want them to be on the flat. And again, it's organization information. It's going to be with all other floor system quantity information, and we'll label them as floor joists. Next, we have a sill plate. When we're putting in a sill plate, do we want a sill plate in? If we want a sill plate in with this floor, then we say, new, I want to add in a sill plate. I want to label it as a sill plate, and I'm going to go out to my catalog and tell it that I want it to be a 2x6 sill plate. Maybe even looking at our pressure-treated elements, I'm going to say a 2x6 treated. There it is. Do I want it rotated? Yes, let's rotate that 90 so it's on its flat. So there's a sill plate. So on my ground floor location, if I'm coming right down on a concrete wall that I'm bearing on, then I'd want the sill plate. If I don't use a sill plate, if this is on a second floor designation, then I can delete out that sill plate as well. And again, choose a phase. I want this to go in with our floor framing materials, and I want it to be designated as a sill plate. So it's all labeled correctly for us. Our band joists, flip it up. There's our two band joists on either side. What product are they? How do I want them to be designated in our quantity information? And that's the same for the rims on the opposite sides, running parallel to our joists. What product are they? What phase and usage do they have? If I come in, once I've inserted this floor and cut an opening in the floor, it wants to know as well what member to use as the header around that opening. We're going to use a 2x10. We've chosen from our catalog, but again, it could be any member, and it's going to be labeled as a header. So there's the information behind the floor. So when I pick this structural floor tool, it's putting in the joists, the rim joist, the band joist, a sill plate if I want it, and the sheathing, all in the orientation that I want. So I'm going to hit cancel out of there, and then select that 2x10 floor, move my cursor inside the building, left click once. It'll find the exterior walls and automatically extend them up to those exterior walls for me because I used structural floor by perimeter. Now I want to remove the structural framing from the garage. I want it to stop at this particular wall right here. So once I have it in, if I have to make adjustments, I'm going to use our cycle select feature that allow me to cycle through the different options that are along that same line of that wall. What I'm cycling through, and I'm just going to rolling the scroll wheel on my mouse, and as I scroll with my scroll wheel on my mouse, you can see it's selecting different things that are along that edge. I'm going to take your eye down here to the lower right-hand corner. As I'm scrolling through, watch that designation. Now it's telling me I have the OSB sheathing surface selected. Now I have the structural floor system selected. Now I have the brick wall, the 2x10, that's my rim joist. There's my sheathing again, and here's my structural floor. What I want to make sure that I have selected is this, my 2x10 floor system. I want the entire system selected because when I move the system, it's going to move that rim joist and those joists all at the same time. I put my cursor up near this arrow that appears, and you can also see that there's a blue square. That's what we call a grip. A grip is where you can pick up something from that point and move it. So just by placing my cursor over top of that blue square, that grip, you'll notice that my cursor changes. 4 arrows going in different directions. That's our move cursor. So by holding down my left mouse button and not letting go, I'm going to drag it down to this wall right here. That removes all of the structural floor framing from that room. I've just stretched it down and said, this is where I want to start my rim joist right there. Let's place it and move it down. So I just held down my left mouse button and dragged it down. Now, with the structural floor still selected, I want to tell it that there's going to be a beam running right here between these walls. I'm not going to have the joist running all the way down. They're going to bear on a beam right here. So with the structural floor still selected, I right-click. Right-clicking brings up my options. I'm going to go down to structural floor, and I'm going to tell it that I want to insert a bearing line. Then I pick the points of where I want that bearing line to start and that to stop. And then it's going to automatically put in that green line. And if I zoom in nice and close, because I know yellow is kind of hard to see over the internet, you can see that the joists overlap each other by 1 foot. I might just select all of those joists, and I'm just going to quickly look at their properties, go to their appearance page, and change their 2D footprint to be black so we can see that a little bit better. There we go. So over top of that bearing line that I used, I've automatically, it overlapped those floor joists because of the settings we put with that structural floor. So it knows to overlap them right there. Okay, so there's our structural floor framing. When you put in the structural floor framing, the added bonus of using it is the members themselves are individual members. So if I wanted to come along and select this one floor joist, I can move it, I can duplicate it, I can replace it with something else, just that one joist. If I had used the floor tool, the floor tool by room, by perimeter, and picking points automatically puts in the floor in those designated areas, just like our structural floor would, but it wouldn't include the sill plate at the very same time. It doesn't have the added tools of being able to put in the bearing line afterwards, and it puts in all of the joists as one element. So when you pick on one joist, you're picking all the joists, so you can't individually change them and redesignate them. So similar tool, but it doesn't have all the bells and whistles, if you will, of being able to customize and change the framing and have them be individual members as well. A lot of information I covered today. I want to leave this last we've used 45 minutes of our time, but I want to use the last 15 minutes for questions, because I did cover a lot of information. And this is probably the heaviest portion of our software. When you dive in a little bit deeper and look at the framing and all of the different options that you have, there's a lot of information there. So I want to make sure that I answer your questions. So as I recap everything that we've learned, I invite you to go to that Go to Meeting window. It should be on the right-hand side of your screen. You'll see a chat panel there. Type in any questions that you have, and they automatically get delivered to me. No one else sees your questions. Never be embarrassed about asking a question during these webinars. Questions are the way we learn, and I want to make sure everyone posts as many questions. If you have an area that kind of seemed a little fuzzy of, can you do that again? I want to see that happen one more time. I'm more than happy to recover any information today. So as I recap, formulate your questions and type them up. So today we talked about framing a wall. I'm going to pop this into a 3D view again. When we look at a wall, the wall itself has properties. The properties of the wall tells it that I'm a framed wall. So if I'm going to look at the building locations information, it's going to apply to this wall because it's a framed wall. Being a framed wall, it needs to know what the default framing member is, and it finds that down here at the very bottom. I need to frame this wall with a 2x4. Also in the properties of a wall, they get designated as load-bearing, yes or no, or automatic. And again, the automatic option designates all exterior walls automatically as a load-bearing wall and all interior walls automatically as a non-load-bearing wall. When we look at those walls then and go to frame them, view framing, display the framing, the walls are automatically framed. And that happens up here under our building locations information. Under the building locations information, each separate location can have framing options. And those framing options tell it how to apply that 2x4 or 2x6 along that wall. And when I look at the framing options, it's taking our studs and applying them at 16 inches on center. Double-clicking on that infill brought up a chart of all different infills that we can choose from. And again, this is in our professional and our construction suite software. Here I can tell it if I need a pressure-treated bottom plate, or if I need blocking halfway up that wall, or maybe I want to redesignate and put some ladder framing up that wall. You can look at all the options that are available in our infill configuration to customize the framing to suit the needs and match how you would frame on site. It also looks at the span table. And the span table itself tells it for each span how to frame around that opening. So anything up to a 10-foot span, we redesignated them as using 2 2x10s. Anything above the 10-foot span but less than 16 feet, it's going to use our 9.5-inch product. Anything over that 16-foot opening size will not frame. It'll come out blank. That'll automatically flag to you that you haven't designated wall span table above that 16 feet. So you need to maybe designate that as something you want to get engineered, or that you want to look at those openings individually and designate how you want to frame them. And after you've chosen all of your defaults of how you want to frame them, if you need to change a particular wall or a particular opening on how it's being framed, that's when you can look at this framing mode on and off. With framing mode on and off, it will wash each of the walls. That allows you to select the framing and how the configuration is applied to that particular opening or wall. Again, the orange walls are load-bearing walls. The green walls are non-load-bearing walls. The rose-colored areas are openings. So if you want to change any of them, you select it and right-click and look at their properties. It'll tell you that it's referring to the building locations, the infill information, but you can also tell it you want to use a custom configuration and then select a different designation for that particular opening, and it will use that. To get back out of framing mode, I come back down to the bottom and tell it framing mode off. To take it all out of framing, I'm going to go to display all but the framing, and I'm going to put it back down into a 2D view. We don't see our floor framing. I want to be able to see my floor framing members, but I don't want to see my wall framing at the same time. And if I go to view framing, display the framing, I'll be able to see my wall studs and my floor joists at the same time. If I want to turn off my wall studs but keep on my floor framing, I'm going to take it out of framing, display all but the framing, come down here to the very bottom to our view filter, where I'm going to tell it to turn on the structural floor framing, and then it'll appear. Using the structural floor tool is similar to using the floor tool, but the structural floor tool has more options. It'll allow us to designate the orientation of the joist, designate a sill plate, a joist, a band joist, a rim joist, and also a subfloor material all at the same time. Once they're in, we can cycle select to select that system. So I'm selecting the wall, but then holding down my shift key and moving my scroll wheel on my mouse to cycle through all of the elements that have an endpoint, a line along that same line. So I can select my structural floor, right click, and then we have options for inserting a bearing line. If we're going to be putting in a beam along that line, we can change that. We can split a floor as well, so if at a certain point they're going to change direction, we want to split them apart, we can do that too. A lot of information, a lot of different things that we covered today, so I want to get right to your questions again. So I'm going to go over to our chat panel, scroll through our questions, and here's our first one. How does bearing line become a drop beam or a flush beam? The beam itself is a separate member. So the joists themselves, when I've selected that structural floor and told it to insert a bearing line, it is just that, it's just a line. To get the actual member in, I would come up to our members tool and insert a member at that point. So I could say, I'm inserting a member. I want that to be a particular member here. I'll use our I'll use a steel beam here, W8 by 24, and insert it at the floor level or below that. I want it to come right underneath my 2 by 10, so I'm going to minus 10 inches for the base height here at the very bottom. So when it goes in, it's going in at the right height. I hit tab to set that, and then I put that in as a separate member. So it doesn't change the line into the member. You have to designate and pick the member size that you want to use for that beam. That's our only question. So I'm going to hold the questions just to ensure that if someone's typing one out, they can, I'll be able to answer it for them. I hope that means that everyone understands where to find all of these options. Again, following today's class, I'm going to send you a booklet that's going to cover that information as well, so you can read about all of those various settings that I did go over about framing, and that'll illustrate them in the booklet as well. But that seems to be the only question that we have for today's class. So again, I want to thank everyone for joining me for today's class and learning about framing in the software and all the various options that are there. It is one of the more advanced classes that we have, looking and diving into all of those various settings that are there. The best way to learn is to get in there and play with it and try those different settings. So when I send out the booklet today, read about the material. I did tape today's class so you can watch it again, and you'll be able to pick up on all those settings. Thanks again, everybody, for joining us today. I hope you have a great week. Thanks, and bye-bye.